Diesel fuel is classified as a Class 2 combustible liquid. This means that it is a flash point above 100 degrees Fahrenheit 38 degrees Celsius but below 140 degrees Fahrenheit 60 degrees Celsius. While diesel is not as volatile as gasoline, it can still present a fire hazard under certain conditions. The 20-foot radius around an above-ground diesel fuel tank is considered a Class 1, Division 2 hazardous location. This means that flammable vapors may be present in normal operation or under abnormal conditions. According to the National Electrical Code, ONEC, Article 501.15, conduits entering an enclosure in a Class 1 or Class 2 hazardous location must be sealed to prevent the passage of flammable vapors. This requirement applies to conduits entering the generator enclosure from the concrete pad, regardless of whether they are within the 20-foot hazardous location radius. Diesel vapors can travel through conduits, especially if the conduits are not properly sealed. In the event of a leak or spill, these vapors could enter the generator enclosure and create an explosive atmosphere. Seal-offs help to prevent this by stopping the flow of vapors. Yes, you need to install seal-offs for the conduits entering the generator from the concrete pad, even though diesel fuel is not specifically mentioned as a flammable liquid in the NEC. Diesel vapors can still present a fire hazard, and the NEC requires conduit seal-offs to mitigate this risk in hazardous locations. Let's delve deeper into the specifics of hazardous locations and the NEC requirements related to diesel generators. Understanding these regulations is crucial for ensuring safety and compliance during installation and operation. Firstly, let's clarify the classification of hazardous locations. The NEC defines hazardous locations based on the type of flammable or combustible materials present and the likelihood of their presence in ignitable concentrations. Class 1 locations involve flammable gases or vapors, Class 2 locations involve combustible dusts, and Class 3 locations involve ignitable fibers or flyings. Within each class, divisions further specify the probability of the hazardous material being present. Division 1 indicates that the material is likely to be present under normal operating conditions, while Division 2 indicates that the material is likely to be present only under abnormal conditions, such as a leak or spill. In the case of a diesel generator with an above-ground fuel tank, the area within 20 feet of the tank is typically classified as a Class 1, Division 2 hazardous location. This classification arises from the possibility of diesel vapors being released during refueling, maintenance, or accidental spills. Even though diesel is less volatile than gasoline, its vapors can still create an explosive atmosphere when mixed with air in the right proportions. Secondly, let's examine the NEC requirements for conduit seal-offs in hazardous locations. Article 501.15 of the NEC outlines the rules for sealing conduits to prevent the propagation of explosions or the communication of flammable vapors or gases. Seal-offs are required in several scenarios, including where conduits pass from a non-hazardous location to a hazardous location, where conduits enter enclosures that are required to be explosion-proof, and where conduits are 2 inches or larger in size entering an enclosure or fitting containing devices that may produce arcs, sparks, or high temperatures. The purpose of seal-offs is to create a barrier that prevents flammable vapors or gases from traveling through the conduit system and potentially reaching a source of ignition, such as electrical equipment or connections. Seal-offs are typically installed using a special sealing compound that is poured into the conduit and allowed to harden, forming a gas-tight and flame-resistant seal. Thirdly, it's important to understand the types of seal-offs available and their proper installation techniques. Seal-offs come in various designs, including those with integral downs, those that require separate downs, and those that are designed for vertical or horizontal installations. The selection of the appropriate type of seal-off depends on the specific application and the requirements of the NEC. Proper installation of seal-offs is crucial for their effectiveness. The conduit must be clean and free of debris before the sealing compound is poured. The sealing compound must be mixed according to the manufacturer's instructions and poured slowly to avoid air pockets. This seal-off must be completely filled with the sealing compound, and the compound must be allowed to harden completely before the system is energized. Fourthly, consider the specific requirements for sealing conduits entering the generator enclosure. The generator enclosure itself may be classified as a hazardous location if it contains components that could ignite flammable vapors, such as the generator's engine or electrical connections. In this case, all conduits entering the enclosure must be sealed, regardless of their size or location. Even if the generator enclosure is not classified as a hazardous location, it is still good practice to seal all conduits entering the enclosure to prevent the ingress of moisture, dust, or other contaminants. This can help to prolong the life of the generator and reduce the risk of electrical problems. Fifthly, consider the grounding and bonding requirements for equipment in hazardous locations. The NEC requires that all electrical equipment in hazardous locations be properly grounded and bonded to minimize the risk of static electricity buildup and electrical shock. Grounding provides a path for fault current to flow back to the source, which helps to trip over current protection devices and to energize the circuit. Bonding ensures that all metal parts of the electrical system are at the same potential, which reduces the risk of voltage differences that could cause sparks or shocks. The grounding and bonding system must be designed and installed in accordance with the requirements of the NEC, and it must be regularly inspected and tested to ensure its effectiveness. Sixthly, let's address the specific situation of the conduits entering the generator through the concrete pad. Even though the conduits are located underground and encased in concrete, they can still be a pathway for flammable vapors to travel into the generator enclosure. The concrete pad may not provide a perfect seal against the ingress of vapors, and the conduits themselves may have cracks or gaps that allow vapors to pass through. Therefore, it is essential to seal the conduits where they enter the generator enclosure, regardless of their location or construction. This will help to prevent the buildup of flammable vapors inside the enclosure and reduce the risk of explosion. Seventhly, let's discuss the importance of regular inspections and maintenance of the electrical system in hazardous locations. The NEC requires that electrical equipment in hazardous locations be inspected and maintained on a regular basis to ensure that it is in safe operating condition. Inspections should include a visual examination of the equipment for signs of damage, corrosion, or wear, as well as testing of the grounding and bonding system to verify its effectiveness. Maintenance should include cleaning, lubrication, and replacement of worn or damaged parts. Any deficiencies identified during inspections or maintenance should be corrected promptly to prevent potential hazards. Eighthly, think about the documentation and record-keeping requirements for electrical installations in hazardous locations. The NEC requires that all electrical installations in hazardous locations be documented and that records be kept of inspections, maintenance, and repairs. This documentation should include drawings, specifications, and other information necessary to understand the design and operation of the electrical system. The record should be kept for the life of the installation and should be made available to authorized personnel for inspection. Proper documentation and record keeping are essential for ensuring the safety and compliance of electrical installations in hazardous locations. Ninthly, we will address the training and qualification requirements for personnel working on electrical equipment in hazardous locations. The NEC requires that personnel working on electrical equipment in hazardous locations be properly trained and qualified to perform their duties safely. This training should include instruction on the hazards associated with flammable materials, the requirements of the NEC, and the proper procedures for installing, inspecting, and maintaining electrical equipment in hazardous locations. Personnel should also be familiar with the use of personal protective equipment, such as respirators and flame-resistant clothing. Only qualified personnel should be allowed to work on electrical equipment in hazardous locations. Tenthly, remember that diesel fuel, while not as readily flammable as gasoline, still poses a significant fire risk, especially when vaporized. The flash point of diesel, as mentioned, is above 100 degrees Fahrenheit, meaning it needs to be heated to that temperature to produce flammable vapors. However, even at low temperatures, diesel can slowly release vapors, particularly in enclosed spaces or during spills. These vapors, when mixed with air, can create a flammable mixture that can be ignited by a spark or hot surface. Therefore, it's crucial not to underestimate the potential hazards associated with diesel fuel and to take all necessary precautions to prevent fires and explosions. 11thly, remember to consult with local authorities and insurance providers regarding specific requirements for diesel generator installations. Local building codes and fire regulations may impose additional requirements beyond those specified in the NEC. Insurance providers may also have specific requirements related to safety and risk management. It's important to consult with these parties to ensure that the installation meets all applicable requirements and that the risks are properly mitigated. 12thly, remember that the presence of other flammable materials in the vicinity of the diesel generator can increase the overall fire risk. For example, if the TV station uses gasoline-powered equipment or stores flammable chemicals nearby, the area may be subject to more stringent hazardous location classifications and electrical installation requirements. It's important to consider all potential sources of flammable materials when assessing the hazardous location classification and designing the electrical system. 13thly, ensure proper ventilation around the diesel generator and fuel tanks to prevent the accumulation of flammable vapors. Adequate ventilation can help to dissipate any vapors that may be released from the fuel tanks or during generator operation. This reduces the concentration of vapors in the air and minimizes the risk of a flammable mixture forming. Ventilation can be achieved through natural means, such as open windows or vents, or through mechanical means, such as exhaust fans. The ventilation system should be designed to effectively remove vapors from the area and should be regularly inspected and maintained. 14thly, install appropriate fire suppression systems to protect the diesel generator and fuel tanks in the event of a fire. Fire suppression systems can help to quickly extinguish a fire and prevent it from spreading to other areas. The type of fire suppression system required will depend on the size and configuration of the installation, as well as the local building codes and fire regulations. Common types of fire suppression systems include automatic sprinkler systems, dry chemical systems, and carbon dioxide systems. The fire suppression system should be designed and installed by qualified professionals and should be regularly inspected and maintained. 15thly, implement a comprehensive safety plan that includes procedures for handling diesel fuel, operating the generator, and responding to emergencies. The safety plan should be written and readily available to all personnel who work with the diesel generator. The plan should include detailed instructions on how to safely refuel the generator, how to start and stop the generator, how to monitor the generator's operation, and how to respond to various types of emergencies such as fires, fuel spills, and equipment failures. The safety plan should be regularly reviewed and updated to reflect changes in the installation or operating procedures. 16thly, it's important to emphasize the importance of using only approved equipment and materials in hazardous locations. The NEC requires that all electrical equipment and materials used in hazardous locations be specifically listed and labeled for that purpose. This means that the equipment has been tested and certified by a recognized testing laboratory to meet the safety requirements for hazardous locations. Using non-approved equipment or materials can increase the risk of fire or explosion and can void the warranty on the equipment. 17thly, it is prudent to consider the use of intrinsically safe equipment in certain applications within the hazardous location. Intrinsically safe equipment is designed to operate with very low energy levels, so that it cannot produce a spark or hot surface capable of igniting flammable vapors. Intrinsically safe equipment is often used for instrumentation, control, and communication circuits in hazardous locations. 18thly, remember that the information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. The design and installation of electrical systems in hazardous locations should be performed by qualified professionals who are familiar with the requirements of the NEC and other applicable codes and regulations. These professionals can assess the specific risks associated with the installation and design a system that meets all safety requirements. 19thly, think about surge protection for the generator and associated electrical equipment. Power surges can damage sensitive electronic components and increase the risk of equipment failure. Surge protection devices should be installed to protect the generator and associated equipment from damage caused by power surges. The surge protection devices should be selected based on the voltage and current requirements of the equipment being protected and should be installed in accordance with the manufacturer's instructions. 20thly, consider the use of remote monitoring and control systems for the diesel generator. Remote monitoring and control systems can allow personnel to monitor the generator's operation from a remote location and to start and stop the generator remotely. This can be particularly useful in situations where the generator is located in a remote or difficult to access area. Remote monitoring and control systems can also provide alerts in the event of a problem, such as a low fuel level or an equipment failure. 21st, consider that the NEC provides tables and guidelines for determining the appropriate size and type of conduit for different applications. These tables take into account factors such as the number and size of conductors, the length of the conduit run, and the ambient temperature. Using the correct size and type of conduit is essential for ensuring that the conductors are properly protected and that the electrical system operates safely and efficiently. 22nd, consider the potential for corrosion in the conduit system, especially if the generator is located in a coastal area or other corrosive environment. Corrosion can damage the conduit and conductors and can increase the risk of electrical problems. To prevent corrosion, use corrosion-resistant materials such as PVC or stainless steel and apply a protective coating to the conduit. Regularly inspect the conduit system for signs of corrosion and replace any damaged components. 23rd, also consider the impact of temperature on the performance of the electrical system. High temperatures can reduce the ampacity of conductors and can damage insulation. Low temperatures can make conductors brittle and can increase the risk of cracking. To mitigate the effects of temperature, select conductors and equipment that are rated for the expected temperature range and provide adequate ventilation to prevent overheating. 24th, when selecting conductors, consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to operate inefficiently or to fail altogether. To minimize voltage drop, use larger conductors or run the conductors over a shorter distance. 25th, document all aspects of the generator installation, including the location of the generator, the type of fuel used, the size and type of conductors, the location of seal-offs, and the results of any testing or inspections. This documentation will be helpful for future maintenance and troubleshooting and will also be required for insurance purposes. 26. Adhere to all applicable local, state, and federal regulations regarding the installation and operation of diesel generators. These regulations may cover a wide range of topics including air emissions, noise levels, and fuel storage. Failure to comply with these regulations can result in fines or other penalties. 27th. Provide adequate training to all personnel who will be operating or maintaining the diesel generator. This training should cover all aspects of the generator's operation, including startup and shutdown procedures, safety precautions, and troubleshooting techniques. 28th. Implement a regular maintenance program for the diesel generator. This program should include regular inspections, oil changes, filter replacements, and other preventative maintenance tasks. A well-maintained generator will operate more efficiently and reliably and will be less likely to experience breakdowns. 29. Develop a contingency plan for power outages. This plan should outline the steps that will be taken to restore power in the event of an outage, including the use of the diesel generator. The plan should also include procedures for communicating with employees, customers, and other stakeholders. 30th. Consider the environmental impact of the diesel generator. Diesel generators can produce air pollution and noise pollution. To minimize the environmental impact of the generator, use a low-emission engine, install noise reduction equipment, and properly dispose of waste oil and other materials. 31st. Coordinate with the local utility company regarding the connection of the diesel generator to the electrical grid. In some cases, it may be possible to connect the generator to the grid to provide backup power or to sell excess power back to the utility. However, this requires careful coordination with the utility company to ensure that the connection is safe and reliable. 32nd. Be aware of the potential for theft or vandalism of the diesel generator. Generators are often targeted by thieves, so it is important to take steps to protect the generator from theft or vandalism. This may include installing security fencing, security cameras, and alarms. 33rd, ensure that the diesel generator is properly insured. This insurance should cover damage to the generator, as well as liability for any injuries or damages caused by the generator. 34th, review and update the safety plan and maintenance program on a regular basis. This will help to ensure that the generator is operating safely and reliably and that the facility is prepared for any power outages or other emergencies.